So we're ready to go. Good. What's up, you scholars of enlightenment? Welcome back to another Bad Boy Meets. It's pretty clear that most of us act differently when we believe we're being watched. I know I certainly do. But now a new study has revealed that thousands of stars beyond our solar system may provide a vantage point from which aliens could realize that our planet exists. So in short, aliens might be watching us. After all, if we're looking for exoplanets, doesn't it make sense that intelligent aliens would be looking for them too, potentially using some of the same methods that we utilize here on the Earth? So to ponder that deep question and unravel that recent study, we welcome Dr. Jackie Faherty, one of the study's authors, to the show. Dr. Faherty, thank you very much for joining us.
Hi, Sam. Yeah, I'm very excited to talk to you today.
Excellent. And you have a fantastic background for the topic in hand. So Dr. Faherty is a senior scientist and senior education manager jointly at the Department of Astrophysics and the Department of Education at the American Museum of Natural History, and works at the forefront of brown dwarf and exoplanet atmosphere detection and characterization. And she also has a passion for unique outreach activities, like joining me for this morning talk, I guess. So, Dr. Faherty, what methods do we typically use when we're looking to locate exoplanets, planets beyond our solar system?
Yeah, there's a couple of methods that currently exist that astronomers use. The one that most people can probably relate to is by using your eyeball, or how the first few planets were discovered, or the planets in our solar system, I should say. So, we discovered Jupiter and Saturn, Mars, by looking up and seeing them. And so we call that method direct imaging.
Yep.
And that, is a great method, but most planets are too close to their host star, and you're not going to see them. They're too faint when they're not in our solar system. So we don't use direct imaging. Is just a harder method to utilize. We've only found a handful of planets that way. The most popular by number method of discovering planets is something called the transiting method. And that's akin to, Sam, did you see the transit of Venus that happened in 2012, I think it was?
I did not, but I do have this nice handy little YouTube video, if that is helpful for you to kind of...
So that might look familiar to some folks that might have seen the transit of Venus. You can play it one more time, maybe.
Yeah, and I'll pause it in the middle, perhaps, for...
Yeah, there you go. Right. Like, so those that may have seen the transit of Venus might say, oh, hey, that kind of looks like what I saw. You were seeing from Earth was Venus crossing the disk of the sun. And when it did that, the sun's light dimmed ever so slightly, indicating to us if we hadn't already known Venus was there, we would have had an idea that Venus was there. And so that is the method that we use across our views of the galaxy to look for stars that have a planet from our vantage point cross between your eye and the disk of that star. And so we call this the transit method. It's super efficient. Well, should I say that? Not super. It's very good at finding planets, in part because you can do tons of stars all at once and find the small number of them that are aligned really well so that you can actually detect that planet crossing in front. So about 70% of the planets that we know of right now, and there's just over 4,400 or so, were found with this method.
Wow. So that's a very large fraction and a huge number of planets now that we've found outside our solar system.
Yeah.
So if we turn this on our head and think we do this, so obviously the intelligent aliens, we would expect to be doing something similar. How did you come up with this idea of flipping it on its head and looking from the other perspective?
Yeah, so what happened was my friend and colleague, Lisa Kaltenegger, who's an astrophysicist at Cornell University, she's actually the director of the Carl Sagan Institute, which is kind of an invitation to think outside of the box. Lisa had worked on the idea in a paper which just said how many stars right now are just statically in the right position to see Earth as a transiting planet. And then she came to me and said, Jackie, do you think we can do this over time? And I'm a dynamicist, so I'm somebody that looks at things, looks at the way stars move. I visualize how stars move. I work at the Hayden Planetarium, so I'm constantly thinking of cool visualizations that I can do. And so Lisa came to me with the idea, and I was like, yes, we can totally do this. And so the uniqueness of what we tried was both reversing the vantage point of saying, hey, let's just hold a mirror up to ourselves in our own searches for other worlds and just reverse the question and say, how many of them could see us, and do it the right way, which is over time.
Yes.
Because a snapshot's not going to tell you everything. You need to know,
because the alignments are changing with time, and which ones could see us will be a function of time.
Yeah, that plus it takes a year for the Earth to go around the sun. So, it takes Jupiter like 13 years. So you're looking at time as a huge factor.
Yeah.
And so both, to your point that you just made, you got to get the alignment right, and the alignment changes because all stars are in motion and we're not all moving in the same direction. We're not all moving with the same velocity. And you have to be able to watch for a while to actually detect a planet.
I see. So there was some previous work done in this area, but it sounds like you've gone the extra step to go away from snapshots, as you say, to being projected more through time. How did you determine how many stars might have been able to see the transit of the Earth, either now, in the past, or in the future? You talked about dynamics. What sort of data do we have to look at, and how do we do that projection forward and backwards in time?
Yeah, and and just to go back for a sec, because you've brought up this excellent paper that Renee Heller led, and Renee really pioneered the idea, Renee Heller, and this planet, the search for extraterrestrial intelligence in Earth's solar transit zone, was a fun idea that they had back in a couple of years ago. However, what they didn't have access to, which we did today, was a catalog created by the European Space Agency. It's called Gaia. Have you heard of Gaia, Sam?
Yeah, I have.
Okay, because Gaia's, I will climb on this hill and die on it. Gaia is the greatest astronomical mission that's ever come to humanity's attention. It is an amazing catalog which maps the positions and the distances and the velocities of almost 2 billion stars, which is insane. And so that's the thing that I focus my attention on every single day. I work on some aspect of the Gaia catalog. I use the motions of the stars that are mapped more precisely than anything we've ever seen before, especially the closest stars, because those are the ones that you can get the highest signal on, you can learn the most about because they're nearby, so that they're brighter.
I'm guessing the errors on those trajectories and distances also kind of scale, or are at least a weak function of distance away from us as well. Is that true?
Yeah, so the farther away you get, the harder it is to do the kinds of measurements that we need to make in order to map the stars precisely. Now, that's also a function of how intrinsically bright the object is.
Sure.
So you can get a very high mass star that's extremely bright that you can see across the galaxy. But the things that I'm really an expert in, brown dwarfs, which are like barely stars, we only can see them basically spitting distance away at, maybe 100 light years away. And then it starts to fall off because we start to lose them because they're too faint. But so Gaia has an amazing map of the nearby solar neighborhood. And that's where we began, which was not available when Renee did the initial catalog. And Renee, in this paper, him and his colleagues also didn't use time as their factor. They just reversed the question to the static view. But as I say, it's like that is an excellent first step.
Yeah. But
time variability of this, the intervals, is critical because of the two factors of stars are all in motion, and you will get zoomed in and out of where you'll be two ships crossing in the night. You'll try and find that planet, and you just are not at the right angle.
Yeah.
Or you're not looking for long enough, and the planet is going to transit, but you're going to be gone before you get enough signal in order to see it. So that was important. So Gaia is the reason why.
So Gaia is the big leap forward. Is it an acronym that means something? I know it's like an Earth goddess, isn't it? I seem to remember from my mythology lessons. But in particle physics, we always have weird acronyms things. I don't know if Gaia means anything or it's just taken from the Earth goddess.
Yeah, no, it's not an acronym. It's a common misconception that people have. They capitalize Gaia, and it's not capitalized. It's capital G and then AIA. And so not an acronym. It didn't need to be an acronym, but it is the short version of describing it is the Billion Star Survey, and that's how you can think of it. But I don't remember where the name, like why they landed on Gaia for it. The precursor to Gaia was called Hipparchus, and it was named after the famous astronomer Hipparchus that helped us understand the shape of the cosmos during his time. And so Gaia was kind of the next gen of that.
I thought it might be like greatest analysis information something from how you're talking about it, but I guess it's just a useful name from mythology. So when you did this analysis and you worked out how many stars might be able to have a vantage point to see the transit of Earth across our sun, how many stars popped out of that analysis as being able to have that vantage point, at least for some point in time, and how wide was that time window?
Yeah, so we were limited. When Lisa first came to me, she said, I want to go back a couple billion years. The Earth's around 2.5 billion. Let's do the whole time frame. And I said, we can't do that because while Gaia is amazing, there is uncertainty that is attached to every star's position, every star's distance, and every star's velocity. And so that means that you can't just go back a billion years and know exactly where the star is.
The errors start to compound on themselves as you go further forward or backwards in time. Exactly.
Yes. And so you can think of stars as our understanding of where they are in space is it's in 3 dimensions, right? Because we have their X, Y, and Z positions, but each one of those has an uncertainty on it. So as they move through space, we're really precise in how we understand their velocities, but there's a cone of uncertainty that grows over time. And so at a certain point, you don't have enough of a precision to find this really tiny window. The Earth transit zone, as we call it, window, is less than 0.5 degree in size. And so because of that, we wanted to be sure that we had a time span that wasn't going to make our certainty on when they would enter or exit, large enough that we wouldn't be a useful catalog. So we chose plus or minus 5,000 years. The other important factor here is that we didn't include the full velocities of the stars. I just used the proper motions, which is kind of like the 2D projected velocity, and kind of like how you can see a plane moving across the sky, but you don't know if it's moving towards or away from you.
Yeah.
And that's because Gaia hasn't provided us with the numbers yet for the majority of stars. It will by next year. So that's a notice for your audience to get excited that Gaia is about to come out with another.
Gaia is getting even better than it's been described today. So
yeah, that's right. The Gaia is continuing to give. It's the observatory that gives and gives and gives. And so we did plus or minus 5,000 years. Because I didn't include that. And stars will turn because there's a gravitational potential of the center of the galaxy. And so I just did their straight motion, which works fine for a 5,000 plus or minus 5,000 year or a 10,000 year period, with absolute certainty that we could tell you that they are entering and exiting the Earth transit zone. If I wanted to do a longer time span, I need that extra velocity component, which will be coming. And then I need to do a little bit more. There's more to try to get the time frame backwards and forwards. And so that's upcoming work, I will say.
I guess it's kind of an interesting time frame as well anyway, because it's sort of a time frame that we can sort of conceptualize going forward, and also back into time is sort of, we're starting to think about the sort of birth of early sort of civilization of humans, and we're starting to talk about Egypt and places like this, I guess. So it's a kind of cool, it's kind of a cool window. I thought there might also be some sort of computing limitations and probably time limitations with running those simulations as well, but maybe that wasn't such a concern, and it was mostly the errors that were involved.
It's mostly errors, yeah.
Most of the errors.
I can run it back a billion years, but I wouldn't trust. And I mean, it would be more computationally intensive, but nothing that we couldn't handle with we have a cluster at AMNH, at the American Museum of Natural History where I work. I could have run it properly, but I know that I wouldn't have a secure catalog if I tried that. Maybe in the future, I'm hoping to go back a couple of million years.
Yeah.
And we'll see what we will see in an upcoming paper.
So how many planets popped out from here's the paper. How many stars, first of all, popped out as having had a vantage point, or will be about to have a vantage point in that time window, plus or minus 5,000 years from now?
Yeah, so we broke it down into, there's kind of like three parts. There's those that saw us in the past and are seeing us now. Those that can see us in the future.
Yep.
And so there were 1,715 stars. And it's also important to know that we capped the distance as well.
Yep.
So Gaia provides 1.7 billion stars, and that is the full length of the catalog that they have. Now, we only did the Gaia catalog of nearby stars, which has 331,312 stars in it. And those are the stars that are within roughly 300 light years. So you can guess why we chose the nearest stars, and for a number of good reasons why. I
mean, how are they ever going to be able to get to us if they're much further away than that? So why bother?
Yeah, I mean, that's part of the thought experiment, right?
Exactly.
Where I'm not going to claim that aliens are on all of these worlds, but I will say that the reason why we're doing it in part from like astronomers is that we would love to find a planet around the nearest star. When Proxima Centauri, the closest star, had a planet around it, that was news that like shattered all around the world. Everybody was thrilled beyond belief. Now, why we had other exoplanets? It's because it's so close to us.
Yeah.
So that's the question that we had. Amongst the closest stars, this is what I would call the famous stars. The ones that you know by name, the ones that are Wolf 359, for example. There's a podcast, a really fun audio podcast called Wolf 359. Yeah. It's a Star Trek character. Like, people are into the name of that star, the fifth closest system to the sun. It grabs
the popular imagination straight away, as well as being inherently interesting from a scientific perspective.
Right. And so 1,715 saw us in the past through the present, and 2,034 in total when we include the couple hundred that come in for future viewings of our solar system and seeing Earth. And so in total, it's 2,034 stars over a plus or minus 5,000 year period.
How many of those? So we're talking there about stars, but obviously, if we want to talk about life or potentially intelligent alien astronomers looking back at us, as far as we know, they're not going to be living on stars, although I guess there's probably some form of weird life that we haven't considered. How many of those stars with vantage points have exoplanets that we know of at the moment? So you said about 2,000 stars. How many of those do we know have exoplanets, if any?
Yeah, you just brought up an image of probably the most famous exoplanet system in our list, and that was the TRAPPIST-1 system. So there were, amongst the 2,034 stars, 7 of them have known worlds. And I say known worlds because some of them have more than one planet around them, and TRAPPIST has 7 that we know about. There's several others. Teegarden star, another famous named star that has some close-in planets. Ross 128, another one that's up here. And so when you say how many of them have them, these are the ones that we know right now.
So there could even be more that we haven't detected, but at least 7 different stars and multiple planets potentially for those 7 stars. Is that correct?
Among the 7 stars, each one of them, there's at least 7 that has at least one, but up to 7 planets around them. So, that list of planets that might be in the zone that might have a world around them is not small. Oh, are you still there?
I'm still there. Can you hear me?
Good. Yeah, I got you. It's just something crapped out on my computer.
Not to worry.
But so those are the worlds. Now that you got to take it with a grain of salt, because this is the other thing that we think in astronomy right now. When you take the conservative occurrence rate, the rate at which we think that you could find a habitable world, we think it's close to like maybe 20-25%. So that's kind of like 20 to 25% of stars have a rocky world around them. So you can extrapolate that, take 25% of the 2034. We haven't found them yet. That's just because there's limitations to all of our detections. All of our transiting method, there's limitations to it. The radial velocity method, which I didn't bring up, but it's where you have to spend a lot of telescope time and look at the stars wobble. The direct imaging method that I did mention, that one's really hard and doesn't provide a lot of parameter space for where you can find a planet. So just because you don't find one doesn't mean it's not there. It just means they're hard to find. But 7 of them definitely have planets around them. Cool.
So there's quite a few planets, even in that restricted survey, that could potentially be looking back at us. I found it really interesting that a couple of the examples that came up. So this TRAPPIST-1 system, this is one of the ones that you sort of categorized as not seeing us now, but will be able to see us in the future. So it's going to come into that transit zone in 1,600 years. Ross, someone's put theoretical. They made a mistake on the slide, but that wasn't me. This Ross 128b system saw us in the 10th century BC to the 10th century AD. So it saw things like Alexander the Great, the fall of Rome, the zenith of the Mayan civilization are potentially things it might have been able to see, or the state of the earth during those things. So gives you a kind of idea of that kind of timescale. Is there anything that we can do with this information? Obviously, it's very interesting to think that aliens could be looking back at us. Is there any way that we can utilize this information potentially to help us make contact or do anything else of use?
Yeah, well, so the question would be, should we beam signals in that direction?
Yes.
And, when we were working on this paper and then writing up this paper, Lisa and I had a lot of conversations about a series of books that I was reading. It's called The 3-Body Problem. Have you read The 3-Body Problem?
I am aware of it, but I haven't read it.
I would highly recommend it. Even read a fun article about our survey and then read the book, because it was on my mind a lot. And in this idea of, should we send a signal out to be found or to indicate that we're here? So, this is an ultimate question that humans do face on our next stage of space exploration, because we don't know what other civilizations might be like. So our suggestion was that this catalog could be used for the Search for Extraterrestrial Intelligence, or SETI project, which is focusing using telescopes such as the ones that you've brought up here to see if you can get an artificial signal from any one of those stars. So you would listen, and I quote unquote listen because you're not actually listening to anything. You're just seeing if they're giving off electromagnetic radiation at radio wavelengths, which would be indicative of a non-natural phenomenon. It's not some chemistry that's going on throughout the galaxy. It's like somebody broadcasting.
Yeah.
And you would check those stars to see if they are giving off that signal, similar to how the Earth is doing it. We are broadcasting out into space. And so our suggestion, which SETI, the Search for Extraterrestrial Intelligence collaboration, was very excited about the paper, as this catalog of stars felt like a really good place to focus some of the intention. Because, there's billions of stars. You can focus on any one of them.
Yeah.
But this gives you the closest 2,034 stars that may very well have found us or will find us.
So they could see our transit and then think, is there any other information we can get here that there might be intelligent life there? Oh, here's a radio signal. So
exactly,
they kind of nicely line up with the two. I saw a couple of other suggestions. You sort of alluded to the idea of, whether we should send signals or not. Some people are worried about these civilizations being aggressive or as not having a good outcome from doing this kind of thing. My friend from Cambridge, he's now over at Columbia. I'm sure you know of him, Dave Kipping, who's a professor over there. He had a little idea in a paper, a cloaking device for transiting planets. The idea being that you could fill in that transit with a laser beam on the Earth and effectively block that out. So I guess that's another more negative way that we could deal with the situation, to hide ourselves from somewhere like TRAPPIST-1, or do the opposite of messing with the transit signal so that it looks even more quirky, so you can't fit it with a traditional signal, which would really give away our presence in the solar system. So right. I guess there are a few ideas that people have had, direct signals, as you say, and also kind of tweaking, messing slightly with that transit signal that could really give away our presence to other civilizations, which would be, really cool. Maybe we can't get to each other, but at least we both know that each other are there.
Yeah, I really liked this paper that Dave Kipping had put out, and I had kept bringing it up to Lisa too as we were talking through this paper, as we kept coming down to this, like, should we cloak? Should we not cloak? Like, how are you feeling today? Because as we were going through the catalog, I'm a scientist, but I've got emotions. And so I had feelings as we were looking at the numbers, and I was looking at the stars that were there, because I study the solar neighborhood. So there were names popping up that I knew very well, stars that I had spent a lot of time studying. And all of a sudden it got that reverse feeling of like, oh, they can find us. I didn't know. It was like somebody was watching me through the window, I just turned, and there they were, and didn't realize that, the window was open and the shades were open and the light was on. And so, there you are. And
of course, Dave also had this idea of the terrascope, so they can also see you exactly what you're doing in your office now, apparently. So, it does make you, give you an awkward feeling of being watched, even if they, can't see us like we can see each other now. It's still, like you say, there's still a sort of emotional sort of feeling in the gut that somebody could be looking back at us. People talk about that, sort of generic feeling of looking up and wondering if anyone's watching. It gives you that sort of visceral feeling again.
It does, but it got me into the mindset, which I think Dave is in a lot, Kipping is in a lot, which is the, think of the next gen idea that you might want to consider, because we're not so far off from being a detectable planet where other civilizations could find us. And I base that on how well we're doing, how well humans are doing here, how close we've come to detecting life, real, genuine life from a different civilization. It feels like we're always on the precipice of the discovery. So to me, that was also this like striking reminder as we went through this catalog that these are our closest neighbors. These are the ones that we're kind of all in the same area with, and we did a very, very conservative time baseline. So we've all been with each other for a while, like plus or minus 5,000 years. And just as we found the TRAPPIST worlds, they're about to find us through the same method. If they, if there's anybody there and they're using the transit method. I found that reverse moment really striking as a scientist, that it felt like maybe we need to really consider ideas like this that Dave has been putting out there. Should we cloak? Should we not cloak? We at least need to have the idea on the table.
Yeah. And in 16 centuries, who knows? We might have the warp drives and the ability to go to these places. So it's kind of, who knows what sort of technology will be at our disposal when they come into this point.
This morning, I was listening to Richard Branson on NPR, who's about to go into his suborbital travel. And it was like that moment where I was like, yeah, there's a lot going on right now. We are making big moves in space exploration. And, we've made big moves in the past. Apollo was a huge, big move that didn't really take us that far, but it does seem like there's a push right now. And so that on my mind, I've got this paper that I've been working on for the past couple of months, plus thinking about that. These all kind of come together from my vantage point of like, something's happening. Like humanity's doing a big step forward.
No, it's incredibly cool. Your paper, we talked about direct signals briefly there. Your paper mentions that human-made radio waves have swept over 75 of the closest stars on the list that you determined. How did you determine that? What sort of signals is that? And I guess that has relevance to be able to send more signals.
Yeah, so that's basically, it goes back to when we started broadcasting across this planet. And that happened about 100 years ago. So if you've ever seen the movie Contact.
Yeah, they have the Nazi or Hitler going off on one, I think, don't they, that they detected from us, the leakage of the broadcast into space.
Yeah, so it was basically the first signal that came. They send it, the alien civilization that detects it just turns it around and sends it back, and it's around the star Vega, very famous star. No worries, Vega is not in the Earth transit zone. Even though a recent paper did come out and say that it might have a planet around it. So, but what is happening is that we are sending radio signals off of this planet because we broadcast. We have television. YouTube isn't necessarily counting right now, but we are sending signals in the AM, and those signals leave Earth, leave the solar system, and go out in all directions. They get weaker the farther away they get, but the first signals that would have left Earth have washed over roughly the 100 light year sample of stars. And so we grabbed that sample of stars and we said, how many of those are in the Earth?
So it's like a sphere where the length is the speed of light times the time that we've been transmitting these kind of signals into space.
Exactly.
And whoever falls inside that sphere gets that makes the 75. That makes sense. Okay, that's really interesting. So again, they'd be getting the 20th century view of the Earth and all the horrible things that happened, I guess, and the amazing things that happened as well, which is a really cool realization. So as we sort of come to the end of this, how could we extend this? I've got one question about how we could extend this and one question about more of your kind of emotional reaction to this. So how could we extend this to even more planets? You said we restricted on distance, and the Gaia catalog needs that extra information. Although I guess we could also extend on method. Is that possible with the Gaia data, using more than just transits?
So the ideal part of the transit method is it basically extends the arm of the the visual plane that the Earth would transit the sun across the whole galaxy. The other methods, so like direct imaging, for instance, any star could potentially discover us that way, depending on what side of the sun we're on, but any given world could. We know how hard those methods are. Radial velocity is similar. Any star could potentially detect us through these methods, but they are very time consuming and expensive methods, which is why we focused on the one that was our primary go-to right now, with the intention of essentially holding the mirror up to ourselves. Now, could an alien civilization have basically a 30-meter James Webb Space Telescope orbit around them, and they could detect it via direct imaging? Yes, they could. And so the more important thing is to like keep remembering.
We always have that human-centric bias, don't we? There's always an element of that in everything we do.
Yeah. I mean, the most critical things that we could do, we can increase our volume, that's for sure. And in adding this component, this velocity component, will enable us to really do the backwards and forwards in time, which is critical, I find, to reflecting on our own transit method techniques right now. Because we are staring at hundreds of thousands of stars. The Transiting Exoplanet Survey, called TESS, that NASA has, is looking at the whole sky for transiting worlds, and it's finding them, but you don't find them everywhere. And that's in part because transiting has to line up. Yeah. So part of me did this catalog so I could learn about the lineup issues and how long you stay in a good vantage point to detect a transiting world. And then the other thing that we can do with a catalog of this kind is we should focus on these stars. We should look towards these stars. There are some of them in that list, if you look at the paper carefully, that no one's looked at before. They're new discoveries in Gaia. Gaia provided a distance, Gaia provided a velocity, and so we know exactly how far away the star is, but no one's looked at those stars before. They don't even have good names. Their names are Gaia DR2 and then a really long number.
Faherty 01. Come on, let's get going, and that's one down.
Yeah, well, so my focus is on some of those stars that are unknowns that may very well be the next exciting transiting worlds the next exciting worlds that we find around those stars. And then we can focus on them to listen to them. We don't have to broadcast. We don't have to worry about, us sending the signal out, but we can spy on them.
Yeah. So it's a really useful guide to future research. I wanted to ask you one final question. It's more, if you'll permit me to kind of switch a little bit from being a scientist to being more of a journalist. You mentioned in some of the kind of journalism surrounding this, so we saw the kind of Scientific American write-up of the paper, that it made you feel a little bit like ships passing in the night. So it strikes me that there's a kind of big problem with this, is that these lineups where they can potentially see us in galactic terms, they don't last very long. And if we look at something like, even something as simplistic as the Drake equation, you have to be ready to be able to do this sort of, advanced looking off into the galaxy, doing these transiting methods. So you have to have developed the technology to be able to do that. You have to be looking at our Earth. You have to be in the right alignment. There seems to be a lot of things that have to line up, and therefore maybe it adds to that sort of idea that maybe it's not so unlikely that civilizations just have missed one another so far. Maybe it gives us some hope for the fact that we haven't discovered anyone yet. I don't know how you feel about that idea.
I think you're phrasing it the way I started to think about it. I started to think about all of the parameters, because look, the transiting method is just our go-to right now in our current stage of technical advancement. I don't know how long that lasts for, like maybe we start building an observatory on the moon, or, a large observatory in space that ends up becoming a major go-to for direct imaging or something like that.
Yeah.
Why I felt uncomfortable is because we rely on the transiting method so much in astronomy for detecting worlds and getting to that next moment where we say, okay, is there life there? Can we look for the biosignatures? But to the point that you just made, we like it happens real fast that you're in and out of the transit window.
Yeah.
So you have to look at an enormous sample. And then you're really talking about the worlds that are all the way across the galaxy.
Yeah.
And you are not going to receive their broadcast signal because it's going to be too weak for you. So focusing on the nearby sample made me feel that like it is very possible that we have missed each other and that civilizations pop up, they broadcast. Unfortunately, you're in the wrong timing and you miss each other. And so I both felt good about that and kind of sad, right? Because I would love to be able to find a world and know that it exists in my own lifetime. But I just don't know if that's going to happen.
At least it suggests that the sort of failure we've had to do that so far might not be so unexpected, even if there are people out there. So maybe it says less about the lack of life in the galaxy rather than just the methods and the ways we're going about looking for it, if that's a more hopeful way to look at it. Because like you said, there's so many things that come into this. You have to think of the number of stars we're looking at. Are they aligned correctly? Were we both technologically advanced at that time? Were we looking to hide or not at that time? There's so many factors that multiply upon one another to decide whether we would have been able to use that transit method, as well as the sort of intangibles that you touch upon of what are the technologies that these civilizations might be using beyond the transit method, or maybe they haven't thought about the transit method, they're doing something else.
Yeah, but I also really did reflect on the nearness factor, because there's something to be said about, finding life at something that's close enough to you. Because finding something that is habitable, that's like, in another galaxy, okay, like that feels rough to me. Like, that just feels super rough. They're super far away. I have to stay focused on what I think is tangible. And that's me getting outside of my, rational brain enough, because we don't know how to do that. But it's the nearby stars that I think would make sense. Like, why are we going in Andromeda? That's not going to work. Like, that really doesn't seem to work. But Proxima Centauri feels okay at 4 light years or so. Like, that's not so bad. Even 10 light years or 20 light years. There was something to me about knowing the planets, or sorry, the stars that had been washed over by our signal already. Those feel tangible. And yet, that's a small sample. And even within it, to your point, there's so many factors that go into them that ends up bringing our list real small. And at the same time, the universe is 13 billion years old. We've only been around for 4.5 billion of that. Who knows what went on before humans really started to make their own. We started having recorded history. So that's also a reminder, like, there's a lot we don't know. So,
but you're right, with those close ones, we can start to at least have some conception of how we might get there. People talking about things like Starshot, maybe sending a tiny probe to these things at very high speed. It's at least on the sort of very cusp of possibility that we might be able to do something, even with the science that we have already. So it's very, like you say, I understand the human factor of wanting to focus on those nearer worlds. Yeah,
that to me feels like science fiction that's accessible, as opposed to the other methods that we talk about, let's travel across the galaxy. I feel like we have to lose the physical form. The humans have to lose their physical form. Like, we can't, we're real fragile creatures, we die at the top of a mountain or we die under too much water. Like, we're not very good at adapting in our own environment on this planet. So, I also have to think about that aspect of it. When I think about the kinds of civilizations that might be there and traveling at far distance, you got to be something that doesn't have some neediness like we do.
Yeah.
It has to be some other kind of form of of a thing. And so our own exploration really needs to be done from our own planet right now, and understanding about what kinds of life might exist elsewhere. And so from that, we got to focus on the close stuff, because the close stuff is the easier stuff for us to get access to.
We need to get to the point where we can upload the old consciousness into the friendly androids, I guess. But we're a little bit off, we're a little bit off from that as we go. Dr. Faherty, thank you so much for going through that with us. Really, really fascinating. Really, really interesting. I've learned a lot. It's given me a really interesting new perspective on some of those exoplanets that we see them popping up every now and again in the media. There's an awful lot of them out there, but this gives a really unique new spin on how important those discoveries are and what we could get from them. Is there anywhere you'd like to point people to kind of learn more about this or learn more about what you're saying and what you're doing? You said you do a lot of outreach, so can we direct people anywhere to find out what you're doing?
You can, I'm most active on Twitter. My handle is @JFaherty. And on that, I usually post lots of opportunities for outreach that we're doing at AMNH, as well as programs that we have at AMNH that people can participate in. We have an awesome master's program where we train teachers on how to be earth science teachers, and you get to learn from us inside of the Hayden Planetarium. I teach class on space studies inside of the dome of the planetarium, which I think is very special.
Nice.
So that's an opportunity. But you can follow me on social media there and see lots of the opportunities that pop up all the time to participate in science outreach or even science research, because I co-run a citizen science project called Backyard Worlds, because I'm super into our backyard.
Good.
And that's a fun opportunity too.
Awesome. So everyone head over there, see the interesting opportunities that you can get involved with. I'm sure there'll be a lot of people who are actually really interested in that. Hopefully we can get some of them over there. Dr. Faherty, thank you so much again. I really appreciate you taking the time. I know you're very busy, and hopefully we can get you back. What's the next thing? What's the next development for this paper, or is it on to the next thing now?
Well, I've got another major paper that's going to come out in the next month or so, and that's on almost a direct imaged planet. So I'll send you a link to that when it comes out. But otherwise, on this, get ready for the more detailed catalog that we're going to work on. That'll go through a longer time period. But that'll be relying on Gaia DR3, the Data Release 3 catalog, which is coming up in the next 12 months or so.
Awesome. So maybe I'll be banging on the email in a couple of months' time. Thank you so much again. And hopefully when that comes down the pipe, we can get you back and we can have another fascinating discussion.
Cool. Sounds good, Sam.
It was really fun to talk. Thank you so much.
Bye. And bye, everybody.
Bye.